Hello everybody, my name is Dagmar Jähnig. I'm from AEE Intec in Austria and I'm responsible for use case number 17, which is called Linking Building Simulation to a Physical Building in Real Time. This is the outline of my talk. I will tell you something about the use case in general and then about the engineering phases we defined and about the work package 2 objectives and how we match them in our use case. The use case deals with the automated optimization of the building services during the operation phase of a building. The benefits of an automated process are that the building control can adapt to changing boundary conditions. This will lead to reduced energy consumption and increased user comfort. The building services of most buildings are planned and installed based on assumptions for weather data and usage of the building. In most cases, there is no optimization once the building services have been commissioned. In some cases, a monitoring campaign, which can last 1 or 2 years, can lead to an optimization, which is expensive and a manual process. And this is the baseline for our use case. In the new scenario, a newly developed building tracking system allows to cover the building automation system with a simulation model in real time. The model then matches the building at all times. So-called virtual sensors, which are values that are calculated in the simulation model but not measured, can be used for control purposes. Optimized control settings can be calculated and fed back in the building automation system. The engineering process shown here is the process that takes place to provide the optimization service to a specific building project. The main stakeholder is the developer of the building tracker, called stakeholder 1. This stakeholder leads the entire process. In addition, there are 2 other stakeholders, the installer and/or planner of the building services, called stakeholder 2, and the facility manager, who is in charge of the operation of the building services. This is stakeholder 3. All 3 stakeholders work together to define the requirements for the specific building. This includes specifications of the building and its services. Important specifications are, for example, the services to be controlled, the type of building automation system, and possible interfaces to the building tracking system. The functional design is then performed by stakeholder 1, who designs the tool chain that will be realized in the building, depending on the available building automation system, as well as specifies the parameters and algorithms for the optimization process. This is done in cooperation with the planner of the building services. The next step is then procurement and engineering, which is done by stakeholder 1. That means necessary equipment is being purchased and the algorithms necessary for the specific building are configured in the building tracker. Once the building tracking system is designed and engineered, it can be deployed and commissioned by stakeholder 2. The operation of the system is the task of stakeholder 3, which is the facility management. The preparation and training material and conduction of training courses is done by stakeholder 1, who trains the other stakeholders. Input to the training comes from the functional design phase and the engineering phase in order to fit the training to the specific building case. Stakeholder 3 is responsible for maintenance. An evolution of the optimization system based on the experiences and feedback from users can then be done by stakeholder 1, which will then lead to new requirements. This will start a new engineering process, which may lead to updated algorithms or updated software for the building tracking system of that specific building. However, the use case concentrates on the operation phase of the provided service, optimization of building operation, and develops a tool chain and some of the required tools to accomplish this service. The engineering phases, requirements, functional design, procurement and engineering, and deployment and commissioning are executed for the setup of the service in the demonstration building, but are not part of the tool chain. Regarding the objectives of Work Package 2, the first objective concerns runtime engineering. As explained before, there is the possibility to update the building tracking software and its algorithms during the operation phase of the system. The experiences during the operation can be used to develop new or improved algorithms for the building tracker. This process can be called runtime engineering. The baseline scenario includes mainly one stakeholder, in many cases a research institute, that conducts a monitoring campaign and suggests improvements of the building services and its controls. The building tracker scenario includes a few stakeholders that are directly involved in the design and operation of the system. Therefore, this matches Objective 2. While the baseline scenario was not automated at all, the building tracking scenario allows to track multiple sensor signals, including the possibility of fault detection and the possibility to feed optimized control signals back in the building automation system. This includes a significant number of inputs and outputs, as suggested by Objective 3. Training activities, as addressed in Objective 4, are an integral part of the use case because it is important to transfer the know-how of the building tracking system from the developer of the building tracker to the other stakeholders. As an outlook to the future, after a number of buildings has been successfully been equipped with the building tracking system, the responsibilities of the stakeholders may change. Some of the engineering phases may be transferred to planners or installers of building automation systems. This may make sense for the functional design phase and the procurement and engineering phase. The building tracker developer could then only be the vendor of the building tracking software as well as of various algorithm options for different building configurations. Thank you very much.